Hi, welcome back. In today's video, we are going to talk about deque. They are double-ended code. And in Python, a deque is a list-like container that allows fast appends and pops from both ends, from the beginning and from the end of the deque. Okay? And there are a few examples why we need to use deque in our codes. So there are faster performance for insertion and deletion as compared to lists in Python. They are efficient for first in, first out queues and also useful for last in, first out system. And they have a fixed length queues for recent data and they support fast rotations. But what these things mean, we're going to dive now into the code to see what are these things that we are talking about. In order to use deque, we are going to have the deque being imported from the collection module. Then we are creating one. Here is the name of my deque, which is deque, and these are the elements 1, 2, 3, 4, and 5. And this deque is created and assigned to deque. Basically, I am printing out the initial deque in the output. As you see, the initial deque, we see 1, 2, 3, 4, and 5. But how can we append some elements into our deque? In order to append from right, we can simply write down deque append. And for example, now I would like to append number 6. And using this code, I can append number 6. So when I run this code, we see after appending 6, deque looks like something like this. So 1, 2, 3, 4, 5, 6. 6 is added on the right side of my initial deque. So here is the code. deque, the name of my deque, and dot append. In parentheses, we write down the value that we want to be added to our deque, and simply I'm printing it here. But what if we want to append one element from left? In order to append from left, we write down the name of the deque dot append left. In parentheses, we write down the value. Now I am appending one value from the left to my deque, which is 0. The value is 0. When I run this code, you see that after appending 0, this was my previous deque. Now you see 0 has been added from the left-hand side. So previously we learned how to add 6 from the right side. Now we are adding 0 from the left side. So this is how we can append either from right or from left. It's very easy and it's very fast. And in order to pop from right, we simply write down deque, the name of the deque, dot pop, and empty parentheses. So when I run, you see that we are popping from the right. So the 6 is being removed as the last element of my deque. So 0 to 5 is being created there. So 6 has been removed, or let's say we are popping from right simply by using the pop function. And in order to have pop from the left hand side, it's possible to simply write pop left. Okay, so when I run this code, now this is the last version of that we had. After that, we did the popping from left. So 0 has been removed as well. So 0, we don't have it. 6, we don't have it anymore. Now we are having a deque like this. 1, 2, 3, 4, and 5. Then in order to extend our deque, we can have the extend keyword and then the numbers that we want to be added at the right of our deque. So 7, 8, and 9. So when I run this code, on the right side of our deque, we will see 7, 8, and 9. So here, after extending at right, we are having 1, 2, 3, 4, 5. So far, it was the previous version. And then 7, 8, 9 are added to our deque here. Okay. Then in order to extend from left, we can again have the keyword extend, but from left. So extend left. Then we write down the numbers -1, -2, and -3. So when I run this code, we expect to see from the left to be extended. So we are seeing -3, -2, -1, then 1, 2, 3, 4, 5, 6. 6 we don't have, 1 to 5, and then 7, 8, 9. So here is extending from left hand side. We are having -3, -2, -1, and then 1, 2, 3, 4, 5, and then 7, 8, and 9. So when we are extending from left, we are having the lower number being shown on the left part, which is -3 in our case here, okay? And then we are having the rotation on the right hand side. So if we want to rotate from the right, we simply write rotate and we mention by 2. So by 2 values and elements, we would like to rotate them. So 2 values or 2 elements, we want to rotate them. Here you see this was my previous version. When we rotate from right 2 elements, these 8 and 9 are not here on the right side, but they are on the left side. So when rotating from the right side, these two numbers we mentioned because we want to rotate 2 elements. In parentheses, we put the number 2. So we see that these 2 last numbers are assigned to the left side of our deck here. You see 8 and 9 are there. So if we want to rotate from the left side, we can have rotate -2. Now I want to have 2 elements from the left side. So I write down 2 because I want to rotate 2 elements. And I write -2 because I want it to be done from the left side. So when I run this code, these 2, 8, and 9 are back in the last version to where they were. So we are rotating from left and putting them on the right side of our deck here. Then we can create a new deck with a maximum length. For example, here we are having a deck that has 3 elements, and we mentioned that the maximum length of this deck is 5. So now it has 3 elements only, and we print this deck underscore max. So we see that, okay, it has 3 elements, and the maximum size of this deck is 5. Therefore, it has 2 remaining elements to be added. Okay, in order to add new elements, we are adding 40. Let me uncomment them one by one. So now I try to append 40 on the right side of deck max. When I run the code, you see 40 is added there. Okay, now if I uncomment this, we will see 40 and 50 is added. So 10, 20, 30, 40, and 50. And maximum length is 5. So we are having 5 elements. But if I want to append another number, what would happen? So if I add another number, when we are having the maximum number in this deck, because the maximum length is 5 and we are already having 5 elements there. So if I add a new number, it is going to remove this 10 number. This number 10 is going to be removed. So when I run the code, you see now 10 has been removed and 60 has been inserted. If I add another number, 20 will be removed and another number will be inserted here. So in this video, we saw what the deck is and how we can append and pop elements from the right side or from the left side. And also we learned that they are faster, they're having faster performance for insertion and deletion as compared to lists. And we saw that we can have a fixed length size for our data. In this example, we were dealing with a fixed size, and we saw how we can simply have the rotation of our elements. We rotate 2 elements from right, so it means that we took the last 2 elements, insert them in the beginning, and then we can take the first 2 elements and put them on the end of our deck. So it's very easy. And we are going to have some coding exercises to see how the first in, first out would work and how last in, first out would work. So let me review the code. Here is how we created and initialized our deck. Here is how we appended an element from the right side, how we appended from the left side, how we popped from the right side, let's say to delete an element from right side, and how to do that on the left side, how to extend it. We extended and we added these three numbers, how to extend from left, how to extend from right, how to rotate from right by how many elements. So here 2, you can say 5, 3, whatever. How to rotate from left, we must use the minus and then the number of elements like 2, 3, 4, 5. How to declare and create a deck with maximum length and how to print that, and the policy regarding appending new elements to one deck that has a maximum size that we learned about in this video. Thank you for watching. In the following videos, we're going to have some coding exercises with respect to this topic.